Ever wonder what's really going on inside a tool like ChatGPT? Like, what's happening under the hood when you type in a question? Well, you've come to the right place. Today, we're going to break it all down and basically build a large language model from the ground up, conceptually, right here, right now. Okay, so let's get right into it with the biggest question people have. Is something like ChatGPT just a giant, super fast search engine? I mean, it kind of feels that way, right? It's a tempting idea, for sure. But the truth? Well, the truth is a whole lot weirder and way more interesting. So, the short answer? Absolutely not. They're fundamentally different beasts. A database or a search engine, think of it like a librarian. You ask for a specific fact, and it goes to the right shelf and pulls out the book with that exact fact in it. But an LLM? It's more like an author. It doesn't find existing sentences, it writes new ones. It uses everything it's learned about language to generate something that's never been written before. And that's the key. It doesn't know things, it predicts patterns. All right, so if it's not a search engine, what is it? To really get a grip on this, we kind of need to look at its family tree. Let's figure out where these large language models fit in the huge world of AI. Okay, at the very, very top of the pyramid, you've got this massive concept, artificial intelligence, AI. This is the big dream, right? The idea of creating machines that can think, reason, and learn. Basically, do all the smart stuff that we thought only humans could do. But that's a huge goal. So, how do you even start to make a machine intelligent? Well, one of the most important branches of AI is something called machine learning, or ML. The big idea here is, instead of writing millions of lines of code for every single possible scenario, you just show it. You give the machine a mountain of data and let it figure out the patterns on its own. Now, we go a level deeper. Inside machine learning, there's a really powerful technique called, you guessed it, deep learning. This was the real game changer. It uses these complex webs called neural networks, which are kind of inspired by how our own brains work, to process all that messy, unstructured stuff from the real world. We're talking images, sounds, and crucially for us, human language. And that brings us right to where we want to be, our main topic, large language models, or LLMs. These are a super specialized type of deep learning that is laser focused on just one thing, but it's a massively complex thing, understanding and creating human language. So if you remember one thing, make it this. An LLM is, at its heart, a prediction engine. That's it. It's been fed a mind-boggling amount of text, basically the entire internet, countless books, you name it, all for one purpose, to get really, really good at predicting the next word in a sentence. It sounds simple, right? But that one skill, that's the secret sauce to everything it does. Okay, so we know it's a prediction engine, but how does it actually work? How does it think? Let's pull back the curtain and look at the 4 main steps that happen every single time you type something in and hit enter. This is the core of it all. This whole process can be broken down into 4 stages. First, tokenization, where it chops up your words. Then embedding, where it turns those words into math. Next is contextualization, where it figures out the meaning. And finally, output generation, where it starts writing its reply. Let's take them one by one. So, step 1 is tokenization. A computer can't just read a sentence like you and I can. It needs to break it down into smaller pieces it can handle, and these pieces are called tokens. A token is usually just a word, like cat or house, but sometimes it's smart enough to break up a longer word, like unbelievable, into un and believable to get at the root meaning. Pretty clever. All right, step 2, embedding. This is where it gets a little abstract, but it's cool. Remember, computers only speak math, so each of those tokens has to be turned into a long string of numbers. We call this a vector. The best way to think about it is like this. Imagine a giant invisible map of all the words in the world. Each word's vector is its coordinate on that map. And on this map, words with similar meanings, like king and queen, are super close to each other, while words like king and banana are miles apart. Okay, now for the real magic. Step 3, contextualization. The neural network's job is to look at all those number vectors, all those points on the map, for your entire sentence at the same time. It's looking for the relationships between them. It figures out that in the sentence, the bank of the river, the word bank is totally different from the bank in I need to go to the bank. It's all about understanding the context, which is everything in language. And that brings us to step 4, the final payoff, output generation. So after it's analyzed the context of your prompt, the model does what it does best: it predicts. It looks at the sentence so far and calculates the probability for every single word it knows, trying to find the one that's most likely to come next. It picks that word, adds it to the sentence, and then it does the whole thing again for the next word, and again, building its response one word at a time, all based on probability. So we understand the engine now, but how do we drive this thing? Well, it all boils down to one simple concept: the prompt. You see, a prompt is way more than just a question. It's the entire instruction manual you give the AI for a specific task. It sets the scene, it lays down the rules, and it defines the goal. And I can't stress this enough: the quality of your prompt directly dictates the quality of the answer you're going to get. The simplest way to prompt is what we call a zero-shot prompt. It's exactly what it sounds like. You give it 0 examples. You just ask it to do something straight up, like translate this into Spanish. Because the model has seen so many examples of translation during its training, it usually knows exactly what you want. But you can get way more sophisticated with few-shot prompting. This is where you give the model a couple of examples to get it started. You're showing it the pattern you want it to follow. You're not just telling it the rules of the game. You're playing a few moves to show it how it's done. This is how you get much more specific and accurate answers. So think of these as tools in your toolbox. You've got 0-shot for quick, easy jobs. You've got few-shot when you need to show it a specific format. And for really tough problems, there are even more advanced techniques like chain of thought prompting. That's where you literally tell the AI, think step by step and explain your reasoning. By making it slow down and show its work, you often end up with a much better, more logical answer. And all of this brings us to what might be the most important point of this entire explainer. If these models are just incredibly sophisticated prediction machines, if they don't know anything but just predict what sounds right, what does that mean for the idea of truth? See, they're designed to generate what is statistically plausible, which is not always the same as what is factually correct. And that leaves us with a huge question to think about. As this technology becomes more and more part of our lives, how do we, as humans, figure out what's real?